Initially, the heart consists of a simple tube. It's anchored at one end by the differentiating arterial trunks and at the other by extensive venous channels which drain into the atrium. Being fixed at both ends, the cardiac tube grows rapidly in length, and the embryonic ventricle is bent into a loop to the right of the midline. As development continues, the ventricular region swings back to the midline and expands and grows in length to cover the atrium and great veins. Extensive saculations projecting laterally will ultimately become the right atrium and left atrium. The future left ventricle lies to the left of the interventricular groove, and the embryonic right ventricular or bulboconus region communicates with the truncus arteriosus. A four-chambered heart is formed from this convoluted tube by the development of three septa, partitioning the atria, the ventricles, and the truncus arteriosus. Although these septa develop simultaneously, they will be considered individually. By viewing the heart from the right side, partitioning of the atria and ventricles can be more easily visualized. Externally, a deep groove separates the atrium from the ventricle. Within the heart, the atrioventricular groove appears as a deep invagination, which constricts the atrioventricular canal at its waist. The canal becomes divided along its longitudinal axis by two partitions, growing from the walls of the two common chambers toward the auricular-ventricular junction. Endocardial cushions extend from opposite sides of the atrioventricular aperture and ultimately fuse into a column dividing the channel between the atrium and ventricle. From the interventricular ridge, a proliferating muscular septum advances across the common ventricle toward the base of the heart. Simultaneously, the interatrial septum rapidly grows toward the endocardial cushions, progressively constricting the foramen between the atrial chambers, the foramen primum. Before the foramen primum becomes obliterated, a new opening appears high on the interatrial septum. The timely development of this orifice, the foramen secundum, provides uninterrupted shunting of blood from the right atrium directly into the left. Another interatrial septum, the septum secundum, develops from a ridge just to the right of the septum primum and extends down like a curtain over the interatrial fenestration. The advanced edge of the septum secundum forms the foramen ovale, with the septum primum acting as a unidirectional flutter valve. Thus, blood can flow only from the right atrium to the left. To recapitulate, the common atrioventricular canal is partitioned by the simultaneous proliferation of the endocardial cushions, the muscular interventricular septum, and the interatrial septum. The septum secundum produces the foramen ovale, with the septum primum acting as a membranous valve. An opening persists between the ventricular cavities. Closure of this interventricular foramen awaits the elaboration of a complex spiral septum, which splits the truncus arteriosus and conus region into the aorta and pulmonary artery. The formation of this partition is more clearly seen if the heart is turned by 45 degrees. Originally, the right and left ventricles share a common outflow channel, the truncus arteriosus, which gives rise to the aortic arches. The truncus arteriosus is presented schematically as a transparent cylinder. The bifurcation of the truncus arteriosus, illustrated here, represents two of the aortic arches. The fourth aortic arch forms the aorta, and the sixth is the origin of the pulmonary artery. A pair of ridges which develop at the bifurcation spiral down the truncus arteriosus. They fuse along the axis of the cylinder to produce a single spiral septum, extending down towards the ventricles. The interventricular foramen is obliterated by masses of endocardial tissue from the ventricular septum, by the endocardial cushions, and by the spiral aortic septum. The partitioning of the heart into its component chambers and corresponding arteries is now complete. The significance of the spiral aortic pulmonary septum is more readily appreciated in a frontal view of the heart. The aortic pulmonary septum executes a spiral of 180 degrees and swings into line with the superior margin of the interventricular septum. This process accounts for the manner in which the aortic and pulmonary trunks are entwined in the fully developed heart. Blood from the left ventricle enters the aorta, which passes to the right behind the pulmonary artery. Blood from the right ventricle enters the pulmonary artery, which passes in front of the aorta, turning posteriorly on the left side of the mediastinum. Venous blood from the superior vena cava and the inferior vena cava flows through the right atrium and into the right ventricle. It's ejected into the pulmonary artery, where a major portion continues through the ductus arteriosus into the descending aorta. Resistance to flow through the collapsed lungs is so great that only a small quantity of blood enters the pulmonary arteries. A correspondingly small amount of blood is returned through the pulmonary veins into the left atrium. Oxygenated blood from the placenta enters the inferior vena cava, but tends to stream across the right atrium through the foramen ovale and into the left atrium to supplement the scanty pulmonary venous return. This mixture of venous and oxygenated blood enters the left ventricle and is pumped into the aorta, from which the carotid arteries arise to supply the brain. Through the descending aorta, partially oxygenated blood is distributed to the lower portions of the body. This circulatory pattern persists throughout the remainder of fetal development. Within a very few minutes after delivery into the external world, the supply of oxygenated blood from the placenta is interrupted. If the infant is to survive, respiratory exchange in the lungs must be promptly established. As the lungs become inflated, the resistance to pulmonary blood flow is markedly reduced. Constriction of the ductus arteriosus diverts the entire right ventricular output into the pulmonary circulation. Oxygenated blood returning from the lungs is distributed through the systemic circulation. When the pressure in the left atrium exceeds that in the right atrium, the valvula is pressed over the foramen ovale, and partitioning of the heart is functionally complete.